Hey, what's up, guys? So recently I found this question, and it's interesting. So I want to share with you guys. And if you guys want to see more interesting probability question that I propose a list that is interesting, maybe help for your interview. Although sometimes I still cannot get correct answer at the interview, but I will collect a lot of problem. So hopefully will helps, and hope you guys subscribe my channel. Okay, so the PNB probability that CD is perfect square, compute this. Yeah, this is I didn't write some basic property. So some basic there is a criterion that I didn't I didn't write. So basically, your CD you need to choose a uniformly. Choose a uniform from 1 to n. So basically, your C is randomly chosen from 1 to n, and your D also randomly chosen from 1 to n. And then you ask, oh, if C plus D is a perfect square, so 1 square, 2 square, 3 square, and you want to compute the limit n goes to infinity square root of Pn. Okay, so let's see how to solve this problem. Okay, so simply speaking is that first we should solve Pn, right? So the problem is that how do we solve Pn? Okay, so this is not simple, right? You need to maybe think a little bit, but let's say if C plus D is m squared. So now things C can go from 1 to n. Okay, so obviously that if you can check it, right? If m squared is less or equal to n, then basically let's first assume m squared is less or equal to n. So in this case, that you can have 1 m squared minus 1, 2 m squared minus 2, and up to like m minus 1 and 1, right? So the total solution for this will be for n squared minus 1, right? The total solution will be m squared minus 1. Okay, so basically your Pn is m squared minus 1 if m squared less than n. So you need to sum from m from 1 to square root of n, and then maybe you'll take the floor function. Okay, now you need to add. Okay, so now you need to add the second situation where if m squared greater than n, right? If m squared greater than n, then there will be some constraint here. So let's write out if C plus D is m squared, but now it's greater than n. And notice that the C and D are can both run from 1 to n. So in this case, so D, right? So D can, if D be n, then m squared can be minus n. Notice m squared greater than n, right? So there's a bound for this upper bound is 2n. Okay, so if this is n, then C is m squared minus n, and this is n minus 1. Okay, so you can see that if this n minus 1, then you have m squared minus n plus 1, and then maybe n minus 2, your m squared minus n plus 2, and then keep going, right? But until maybe some points that you cannot keep going down, right? Because D will be smaller and the C will be larger, right? But C cannot exceed 2n. Okay, so maybe up to maybe k, let's say n minus k, and m squared minus n plus k. So your condition is m squared minus n plus k need to be less or equal to n, right? Because C is m most n. So your k is less or equal to greater or equal to m squared minus n plus minus 2n. Okay, so the number of solution is just k minus 1. Okay. Sorry, k plus 1, because n from n minus k, and it's inclusive from both sides. Okay, so it's k plus 1, and k is this. So it's m squared minus 2n plus 1. And for this one, that your m squared is greater than n, so you take the square root of n, and take the floor function at 1, and the square root of 2n, and the floor function, and the 1 divided by n squared. Okay, so let me just write everything down. So your results will be Pn equals to 1 over n squared, m squared minus 1, from 1 to square root of n, this, and the square root of n plus 1 floor function, and 2n, for a function 2n minus m squared plus 1. Okay, so your goal is to just compute this. Okay, so one quick way is to a simple observation. I think everyone knows is that you from n from 1 to less n, you get 1 divided by 6, n plus 1, 2n plus 1. Okay, so if n is large enough, right? The first component will be n cubed divided by 3n plus n cubed. Sorry, m squared. Yeah, sorry, n cube. Okay, so once we have this, then we can write down our Pn will be 1 divided by n squared. And so this one is m squared minus 1, right? So let's write this. So it's square root of n cubed divided by 3. And then let's maybe ignore the first one. And for this one, it's 2n, right? And the square root of 2n, let's see. So let's write it as this. Let's just take the highest one and see. So n minus m squared. So it's like 3 divided by square root of 2n cubed plus square root n cubed divided by 3. That's it. So maybe let's ignore 1. Let's ignore 1 is fine. Okay, let's take a square root of pn, square root n pn. So yeah, so I get, let's see. Okay, so from this case that I get n okay, so this, let's take this. Okay, so from this I know that I only need to take the square root n cubed power. So it's this 2 square root of 2 and 3 divided by 2 and 2 and 3 divided by 2 minus 2 square root of 2 and 3 divided by 2 divided by 3 plus 3 and 3 divided by 2. Okay, so let's collect every number and then see what's going on. So let's cancel every number so you can see this cancel. Cancel. Okay, so the final result should be, let's see. Okay, let's see. So we get 1 divided by third plus 2 square root of 2 minus 2 squared divided by 3 plus 1 divided by 3. Okay, so the answer should be, let's take 3. And then we get 1, 1, 2 minus 4. Minus 6. So it should be minus 4. And 4 square root of 2. Okay, so the answer should be 4 square root of 2 minus 1 divided by 3. Okay, that's it. Okay, so for fun, see you guys next videos.